Okay, we continue on with our current unit. All these wonderful, amazing quadrilaterals. This is the fifth lesson, and for this one, we want to be able to use the properties of trapezoids. Now remember, trapezoids is kind of like the weird uncle of the family, right? Doesn't really blend in with too many of the other shapes, right? How the squares are close related to the rhombus or the rectangle, and of course the rhombus, rectangle, square are all parallelograms. Trapezoid is just a little bit different. And so we're going to take a look at some of the properties. Uh-oh, we just lost a cow. Well, we still have plenty of cows, so that should be okay. So, using properties of trapezoids. Trapezoid is a quadrilateral. In other words, it's got four sides, but exactly one pair of sides are parallel. Right? For the parallelogram, which includes the square, rhombus, and rectangle, they have two pairs of parallel sides. Trapezoid only has one pair. All right, so we've got the bases and we got the legs. Notice how the base angles are paired up. All right, two of the base angles are associated with one base. The other two base angles are associated with the other base. Of course, great thing about this is if I go too fast, you can always hit the pause button. And of course, the legs would be the two sides that are not bases. Now, notice it has to be the two legs that are congruent to be isosceles. Sometimes you'll see one leg is congruent to the shorter base. That does not make it isosceles, right? To be isosceles, we're very specific. It's the two legs that have to be congruent. And if you're wondering why we paired up those base angles, well, if it is an isosceles rectangle, those base angles have to be congruent. Or, if we know there's a pair of congruent base angles, and we know it's isosceles, no, I'll just goof that up. If a trapezoid has a pair of congruent base angles, then it has to be isosceles, right? Because if one pair is going to be congruent, we can deduce the other pair also has to be congruent, and therefore it has to be isosceles. All right, so if we know it's isosceles, we know each pair of base angles is congruent. Or if we just know that one pair of base angles is congruent, we know it's isosceles. Now, each of these quadrilaterals seems to have something special about the diagonals. Right? If you remember previously in a parallelogram, the diagonals had to be perpendicular to each other. Or if you remember the rectangle, the diagonals had to bisect each other. Well, here, if you are a trapezoid, If you are isosceles, the diagonals are going to be congruent. Or if you know the diagonals are congruent, you know it's isosceles. The mid-segment of a trapezoid is parallel to each base. Now notice it does not have to be an isosceles trapezoid. This is true for any old trapezoid. Find the midpoint of one leg, find the midpoint of the other leg, draw your mid-segment, and it will be parallel to the bases. And also, it is the average length of the two bases. Right? So if I add the two bases together, divide by 2, that will get me the length of the mid-segment. Okay, so let's take a look at an example. Now, I know it's a trapezoid because in the diagram, I see exactly one pair of parallel sides labeled. Or if I read the description, it tells me it's a trapezoid. I know it's isosceles because if I look at the diagram, I see that the legs are congruent. Or if I read the description, it tells me it's isosceles. We know the measurement of angle B has to be 120 degrees. So what are all the other angles? Well, you say, whoa, how on earth does that come out to be 60? Remember, we've got parallel lines. Consecutive interior angles have to have a sum of 180 degrees. Angle C, of course, it's got to be congruent to its pair of the base angles. And angle D, that has to be congruent to its partner in crime, right? Angles A and D is one pair of base angles. They have to be congruent. Angles B and C are the other pair. They have to be congruent. Okay, and again, the clues in the picture let me know that I'm dealing with a trapezoid. The clues in the picture also tell me that I must have D as a midpoint and C has to be a midpoint. So I know that the distance from C to D has to be the average of the bases. So I can add the bases together, divide by 2, viola. I know the length of CD is 24. Okay, again, I know it's a trapezoid because I can see the bases are parallel. I know that it's a mid-segment because I can tell each leg is bisected. So I know if I add the bases together and I divide by 2, I have to have the length of the mid-segment. So I'm going to add the bases together. I'll divide by 2. That's set equal to the length of the mid-segment. Of course, what should we do first? Well, let's simplify that numerator. So we'll combine like terms. All right, x plus 3x was 4x. 11 plus 3 made 14. Now, we're really lucky because we could actually reduce that fraction. Right? 2 will divide into both the 4x and the 14. So 4x divided by 2 is 2x. 14 divided by 2 is 7. I can subtract 2x from each side. I can add 2 to each side. And I now know that x is 9. Since the directions just asked me to find x, I can actually stop now. If the directions wanted me to find one of the lengths, then I'd have to keep going. So we're going to have a lovely little worksheet. Oh no, don't tell me it's going to take another cow. It's going to take another cow. No, it's bringing the cow back. That was so nice of it. And besides the worksheet today, we also have another nice little surprise. Ah, just kidding. No, that was the last slide. So there is a worksheet that goes with this assignment.